let's start. So before you is Tanel, and he will talk about how an engineer with no senior title was entitled to upgrade many production and business critical databases in a very stressful time constraint. So here you go, Tanel.
Hi, I'm Tanel, and I'm going to talk about upgrading databases. This was actually not the original title. The original title was something along the lines of how I upgraded a Brazilian RDS database in 48 hours and then flew to Sweden in the morning. So it was, this one sounds like a mundane task that we do every week, but it was actually something that was highly unusual, and just like Tom said, it was quite a stressful time. And you're not really allowed to make any mistakes, but when you rush things, mistakes are bound to happen. But here are things that I tend to talk about, roughly. I'll talk briefly about what Fortumo does, a bit about the technology we use. Yes, we'll talk about what that means for maintenance. How does that change the way you do maintenance, considering we're a global company? And then I'll go into more specifics regarding how we actually did the upgrades, and maybe talk a bit about things that actually went wrong. And I'll try to conclude with some of the lessons we learned, or I learned, doing this as sort of a junior engineer. So, Fortumo is a digital enablement platform. A lot of people think we just do mobile payments. We do that too, and that's a big part of our business, but we also do offer messaging and analytics services to our partners. We have quite a few telcos in over 100 countries. And our advantage is that merchants can connect through us to all of these telcos and offer their products in 100 countries with just one integration, because we've already done all the hard work of connecting with the operators themselves. Our services, we run microservices in AWS. We have Java applications mostly. We have some legacy Ruby stuff and some obscure Python and whatnot in between as well. We use message brokers, RabbitMQ in this case, and our databases are mostly Postgres, but we also have, I believe we have one MySQL database that's running some content delivery system stuff, but yeah, mostly it's Postgres. And yes, I mentioned AWS. So yeah, since we're a global company, we have constant traffic. And when you have constant traffic, you have to bear that in mind whenever you do any maintenance tasks. So uptime may become kind of a problem. So we have to take some special considerations when we do any kind of maintenance tasks. Also, the need for constant uptime is also why we partner with. We use AWS services. They're reliable, scalable, they're secure if you want them to be, and you put in the work to actually make them secure, because they don't offer you super security out of the box. You have to configure stuff. Luckily, we have smart people who can do that. AWS is quite innovative as well. They offer all kinds of new services all the time, and it's good to have a partner that also like drives us forward as well. And the affordability has a question mark in the end. That's mainly because AWS can get super expensive if you don't plan out what you're doing. And since we're in the mobile payments business, like I said, that's a large part of our business. So the margins are quite small, and you have to make sure that infrastructure costs are kept to a minimum. We do that. We use quite small instances in AWS. They're burstable instances, which means that you're given a baseline CPU usage, and as long as you stay below the baseline, everything's good, and your application or your instance keeps collecting credits. So whenever there's a traffic spike and CPU usage goes up, you can actually spend the credits you have earned to cover the extra processing power you will need during that time. And after that, it will revert. Once the spike is over, it will revert back to normal levels and start collecting credits again. So that gives us the safety of handling random traffic peaks that may come at any time. And this applies both for our applications and also for our databases. Our database also use the same types of instances. For a database, we also have databases that run on instances that we manage. AWS manages the instances, but we install Postgres and all that stuff in there. But we also have been converting more and more into RDS, which is Relational Database Service. You can guess 3 times what it does. It's Amazon's own managed database service. So it makes the whole setup quite a lot easier, and you get the scalability benefits that you have with regular AWS instances. And they offer you all kinds of automations, backups, snapshots. These are all really easy to do. And also you can technically do automatic upgrades. I will go into that later why we don't really want to do that. And you can still do quite a lot of customization using parameter groups. So yeah, you can turn on automatic upgrades in RDS, but we generally don't do that. Like I said, we need to have constant uptime or near constant uptime. And whenever we allow someone else to do the upgrades for us, we risk there something going wrong, or there being the database restarting and we'll have a 10-second or 15-second period where no payments are processed, and that's a problem for us. So that's why we want to manage the upgrades ourselves. So yeah, but sometimes there are critical upgrades that AWS will force on you. They will say that in a month we'll do the upgrade for you if you haven't done it, because there are critical security patches that need to be applied. And well, we tried ignoring that, but it turns out that even if you wait a really long time, it doesn't go away, and they still intend to restart and do the upgrade for you. So we found ourselves in a situation where we had to do that in a really short time frame, using an engineer that doesn't really know what he's doing. So it was kind of a challenge for us. Like I said, in-place upgrades, they probably with downtimes, there's a risk of something going wrong, and it will instantly reflect in the application. So if the database, if the main database has an issue, you will definitely have some downtime, and it takes time to get it back online. So for us, it's important that we do the upgrade in a separate instance. We create new database, with a newer version, we migrate over the data and then switch to the new one. Point the application to a different database and everything works. And if it doesn't, we can always switch back. And that will still be quite fast because it's just a configuration change and an application restart. There are several ways of doing data migration for this purpose, but they all have their own benefits. But for us, we decided that since we're cool and using RDS, we should also use some cool AWS tool to do the migration. So we skipped over all the logical replication stuff, which is really cool in Postgres natively, and looked for something that AWS offers. Luckily, they have another service that also gives away what it does in the name. But yeah, it supports several different database engines, also S3, which is their simple storage service, as the source. And it will throw all your data in the new target database, which may or may not be the same, using the same database engine as the source did. And also afterwards, once the bulk data or the main data has been copied over, it will continue to replicate any changes in the source database. It's a relatively simple setup, as you can see on the graph. We have a source database, target database, and a replication instance in between. There are two endpoints that define what kind of database is it connecting to, and other stuff like ports and database names, security groups perhaps, like what kind of access would the instance need. And then you would run a replication task on that instance. And everything will magically work, in theory. We had several challenges that we expected from the get-go. One of those was that an engineering team is only as strong as its weakest member. So it's important that the engineering team shares the knowledge among them. And it was decided long ago, way before we had the 48-hour time limit, that I should be the one that does the upgrades. I, of course, have the help of the rest of the team, but that's a good learning opportunity for me. So that was the first challenge, because I hadn't done anything like this before. Also, we had a tool that we had never used. Not just me, but anyone in Fortumo had never used the tool. So there were also several databases. We had four databases in staging, 4 databases in production. Each of them had a failover database, plus we had 3 staging read replicas and 3 production read replicas that all needed a new version of Postgres. And also the zero downtime is always a challenge, but we kind of have the solution with the whole duplicate the database setup and switch over. Why the zero is in quotes? That's because you can't really have truly zero downtime when you're upgrading. Even the switch takes a couple seconds. And we had to do all that before the next maintenance window. The maintenance window at this point was 48 hours away. We usually do our database migrations, which we have done before, off RDS. It's basically 3 steps. You have a step where you create the checklist that contains all the things you need to do. Then you have a step where you do all of them. And then you have the last step where you hope that everything went the way you want it to. So yeah, that's the simplified thing. Since we were on a timer and we were using a new tool, we had checklists from previous migrations that were done off RDS. But we didn't really have a checklist for the actual RDS upgrades that I was about to do in 48 hours. So it had to be figured out on the go. And I think we did quite well because mostly the steps are the same. The principle of the steps is the same. So we could still use a lot of the work that was done previously. But yeah, this is basically the checklist I came up with. When we wrote it down, it had a lot more content in there, but let's say these are the main steps. And I'm going to go over them. Each of them, I'm going to tell what problems we had on the way. Some of them went quite smoothly, considering the time pressure, but some of them had more issues than we expected. For creating the instances, so like I said, we have the main master database, we have a failover, and we sometimes, usually, have a read replica as well. So you have to create 3 databases with the new version and then migrate data over. Luckily, replicas already get all the data from the master, so you actually only need to migrate data to the master database. The new master database then. This is also the step where you can do any kind of instance type changes or add storage or change naming conventions or do configuration changes. Maybe you want more logging, maybe you want less logging, whatever. So this one could be potentially difficult, but with CloudFormation, that's actually relatively simple because we already have set up from the previous RDS database, and we can reuse the same templates to create the exact same machines, just with a different Postgres version. Plus, RDS already supports the read replicas really nicely. It's basically just one configuration key that says this will be a replica of that database, and everything else it will figure out itself. So creating instances actually went quite easily. For preparing the databases, AWS Data Migration Service actually supports migrating the schema as well. But we didn't quite trust it. I mean, AWS is a great partner and all, but sometimes you need to do things yourself to be sure. So yeah, we created the new tables, users, actually the same tables and users in the new database. Validated that all the users can access the tables they are supposed to. We had to add a couple of parameters that make database migration service work. So it's basically the logical replication key that Postgres natively uses as well. That had to be added to the source database. But otherwise, that was pretty much just running our migration scripts and everything was good. There's also the step of increasing the sequences for all tables. And we do it because AWS doesn't migrate sequences. So if you fail to roll the sequences forward, you will start to have conflicts with the IDs that the sequence table generates because it's thinking that it's getting its first records. The actual database migration service components could have been created with CloudFormation as well. We didn't have much time, as I mentioned, and it didn't really make sense because the database migration is a relatively custom task. Depends on the source and target databases, and you might want to migrate it table by table or the whole thing together. There are too many variables that CloudFormation just didn't make sense for us at the time. So yeah, we went into the AWS console and clicked some buttons, and we had our application instance with access to the source and target database through the endpoint. We set some, I believe it was 200 gigabytes of storage to do the migration. And And you can also test the connections right there in the UI to make sure that the endpoints actually can connect to the databases on either end. So far everything's been going quite smoothly. And we got to the part where we actually create the replication task, started on the instance, and then magic happens, all the data gets migrated over. So you can define any number of tables that will be copied. You can do additional filtering, so you can drop certain rows that don't have a value or have a value that matches X. And the tables are loaded into the replication instance in parallel, so that's supposed to speed the process up by quite a bit. But that didn't quite go so well. There were several issues. First issue that we kind of expected, because I discovered that as we were doing the previous steps, that they don't really support timestamp with time zone, which is a data type in Postgres. They also had no official support for arrays, but they both worked. So that was interesting, because we expected to fight with that, but we instead fought with all the other things that shouldn't have given us trouble at all. Some data types, Postgres has quite a lot of data types, and AWS Migration Service doesn't support most of them. But also most of the Postgres data types are quite strange, and you don't really find them in like normal databases. The ones we had problem with was JSON and JSONB. So AWS tries to handle those as large binary objects, which have a fixed size. But they also have a full LOB mode that is supposed to figure out the size it needs by itself, but it didn't. Instead, it gave us random errors about array data types, which actually, as we discovered later when we switched off the full LOB mode, we discovered that the arrays actually work, but the errors were still given about the arrays, even though the issue was with the JSONB fields and not setting a fixed size. Also, Database Migration Service does not support migrating tables that don't have primary keys, which we didn't anticipate, or at least I didn't anticipate. Maybe others did, but we also had, that caused us to have a couple of tables that we had to migrate manually, just dump them and move them to a separate table. Luckily, these were also tables that aren't actively in use. So yeah, you also get fun stuff. You find fun, like primary key violations when you move the exact same data to a new table that uses the exact same indexes and constraints, which was fun. And perhaps the biggest problem, and what really frightened us at the time, was the fact that we didn't really think about the instance types we use, and that they're not really that powerful. We're usually running on quite small instances with not that much processing power, and our databases run on actually T2 micros, which are the old generation burstable instances. And the Database Migration Service kind of expects that your databases are bigger and can actually handle all the data moving. So what happened is that the credits we had acquired were spent with going over the baseline CPU usage, because the CPU jumped up to, I don't know, 50%. Instantly, and it stayed there the whole time until we got throttled because we ran out of credits. And after that, the migration was super slow. So that was something that really worried us, because we checked the speed in certain points and found that with the bigger tables, we saw that we would move 1 million records in an hour, but we had 60 million records to move in just that one table. So in 48 hours, that brings up all kinds of issues. In the end, what we had to do was the biggest tables were actually still migrated manually using other methods. Actually, we used pgdump for those because these were history tables that contained the most records. But yeah, after we retried and retried and retried again, eventually we managed to actually get through all the data copying. After which we had to do some data verification to actually make sure that the source and target database contain correct data, especially since we were using data types that weren't officially supported. We had to make sure that they were migrated properly. And the database migration service again has built-in validation. And again, we don't fully trust them at times, but there was also the issue that we already, without doing the validations, we ran out of CPU in the source database. So if you do validation queries at the same time as you're moving data, it's just going to die faster. And that's not something we wanted. But yeah, we ran queries that calculated hashes from a certain number of rows and compared to hashes in the source and target databases, and went through it and we're happy with the results. It looks like the database migration service actually works after you get through all the obscurities. And then came the switch, something we've done several times, not with RDS database, but this is the part where the database host doesn't really matter. And I guess the only important part here is that they're prepared. So before doing the switch, since we want to limit it to a couple of seconds, we have to make sure that we have all the queries, all the configuration files, everything ready. And we do that. We did that in pairs. So there was one person who was doing the changes in the instance, and the other one who was monitoring the databases, and we got through them in a few seconds for each switch. And we actually just got through them in a way that when I went home at around 1 a.m. on the last day, and the next morning was the time of the switch, we had actually successfully migrated everything and did all the switches as well. There was still one step that had to be done eventually. That's the cleanup step. But that wasn't really something that we had to do in a rush. We were paying for 2 database stacks, but we suppose it was worth it. You don't really want to do cleanup at 1 a.m. When you're tired, and then you might accidentally just delete the new stack you just created, and everything goes up in flames, and the whole 48 hours of stress was for nothing. So all the cleanup steps were actually done later. After I had come to Sweden and was enjoying my time there, my colleagues picked up the slack and they did any kind of leftover tasks, including some of the migrations, like I said, history tables and such that were dumped and moved manually. They weren't critical and could be done later. There was also an issue where we didn't actually roll the sequences forward in one of the tables, and there were conflicts that my colleagues had to fix, but they didn't seem to mind. At least I didn't hear it because, like I said, I was in Sweden. Yeah, to conclude this whole magic with it, I think there are like several things you have to keep in mind when you do business critical tasks with very limited time frames. this probably also applies to when something goes up in flames in the middle of the night and you have to fix it. But for me, that was the first experience with doing something that mostly I would have been yelled at for doing at Wednesday afternoon, because people are gonna go home soon, and if something breaks then you can't fix it. But yeah, there's the first and most important part is you need to get help. There's no point in doing everything alone. Like I mentioned my colleagues several times, they were actually involved. Like once we realized that we actually had to do it all in 48 hours, they were with me from the get-go. And I was still driving the project at a certain point, but up to a certain point, but I couldn't have done it without them. There were too many things to monitor, too many things to do in parallel, and I would have made a lot more mistakes if I hadn't had anyone at my side. Also, type faster is not the solution when you're doing critical things. You may feel like you're going faster and you're getting more done, but you also increase the already high chance of making errors. And if you make errors, you lose all the time gained by typing faster. So it's important that you rather focus on doing the right things, even if maybe you have to do extra validations at certain steps. It's worth it, because mistakes are really costly when you don't have time. And like already you don't have time for these things. Documentation is also nice. Like I said, we didn't have a checklist, then we had to make one up then as we did the upgrade. I think you should have checklists or documentation for the process you're actually about to do, especially critical ones like these. I mean, after we sorted out the first database, the first switch, since we didn't do them all together, we had sort of a working documentation that we copied over and used for the next one. Did some changes here and there, but overall each next switch was easier, purely thanks to having a list you can follow, and make sure you haven't forgotten about anything, such as rolling up sequences. And this is just the same checklist again, and it's not enough to just follow the checklist point by point. You also have to think about what the next step is. And maybe you can start step 5. You can start validating the data already before the replication has completely finished, or you can start validating certain tables. So you don't have to wait for the previous step always. And it's important that you think about it. Otherwise, you're going to waste the precious little time you have just staring at the computer. Like all your databases are migrating and you're just staring at the computer and waiting for them to finish, and you don't have anything to do. So it's important to plan it accordingly. And always keep in mind what the priorities are. This picture doesn't really make sense here, but I added it here because Rose wanted the cat picture. So yeah, the main priorities. So, what, like I said, we had some trouble in step 4, which was the actual replication or data migration. And we recreated the replication instance several times. We recreated the task several times. We changed the source and target endpoints. We did all kinds of magic there. Because that wasn't really a business critical step. That was something we could play around with. But when we actually got to the important step, which was the actual switch and the data validation, those we were super careful about. So you have to keep in mind that even if you're in a rush, there are some steps where you can rush a bit, and there are some steps that still need your complete focus. And nobody's going to be happy the next day if you say that I created the cloud formation templates for all these components, and we can create the replication instances really easily next time if you actually lost 2 databases worth of data in the process. So focus on the right things, and don't forget why you're doing this. That's it. Thank you.
Thank you, Tanel. Do you have any questions to Tanel? Yes, please.
Did you have any correspondence with Amazon regarding the confusing or lack of the DMS error messages?
No, we didn't.
You have only 48 hours. Come on, man.
Didn't have time to read the whole.
So are you saying that there's still the lack of proper errors there?
I mean, I haven't done that again. I hope I won't have to. But I believe they've improved their database migration service since then, actually a couple of times. Some of the issues I mentioned might not actually be true anymore. I do believe they actually, I think I read about them now supporting tables without primary keys, for example, in database migration service. So perhaps they've also improved the way they throw you random error messages for completely unrelated problems. But you can ask them.
What were the Postgres versions?
Yeah, I didn't mention that. It's horrible. We started out with 9.6 in all cases, I suppose. There might have been one that was 9.4, but they all had the logical replication support that was necessary for running database migration service. And we upgraded to 11.2 at the time. It was in June, I believe. Yes?
So under the step where you're pointing the applications to the new databases, you mentioned wait for the replication lag to disappear. How long was that generally?
That was probably measured in milliseconds. We saw it as a second, maybe. But we had queries ready to check both databases, and we found that they're stuck or waiting at their max ID is the same. They had the same record last time. And yeah, it was generally like under a second.
All right. Thank you again, Tanel. And